It's Darasa Online. My name is Mbarako Marabed, teaching advanced mathematics. Today, we are going to continue with our revision in the topic of probability. So our subject is advanced mathematics. The topic of our revision, still probability. If you remember, in special probability, we have the so-called normal distribution. Now, normal distribution, this one is an extremely important continuous probability distribution in which the mean of the data, the median of the data, and the mode of the data are all equal. That is when you're talking about normal distribution. So normal distribution. In normal distribution, mean equal to mode equal to median. That is when you're talking about normal distribution. But apart from normal distribution, I'm sure you have gone with it in normal classes. Here we're just making revision. We have the so-called normal distribution curve. Normal distribution curve. So when we say normal distribution curve, it's the curve having the following properties. The curve is symmetrical about the mean. That is property number one of normal distribution curve. And the second one, the variable x ranges from negative infinity to positive infinity. And total area under the curve is equal to 1. As you know, the summation of probability is always equal to 1. So when you find the area under the curve of normal distribution, it will always give you 1. So you can divide the graph into two equal parts, that is symmetrical, in which to the right is 0.5 and to the left 0.5. But also, the curve never touches or crosses the x-axis. And the last one, the maximum value of y is approximately. So that one, the maximum value, I'm just writing this, maximum value of y is approximately equal to 2 over 5 times 1 over standard deviation. So these are the 5 characteristics or properties of a normal distribution curve. Now let's see, if you are given a curve, will you be able to interpret the curve? Now if you see here, we have a curve. Our curve here contains 3 different curves. Let's take that number 1. Number 2, it has a standard deviation of 1. That one is standard deviation number 2. And the last one, standard deviation number 3. So if you look clearly, the graphs are different. In the case of maximum value of y, how far is the graph take in vertical cases? I mean the maximum value of y. Now from this graph, we can say, for standard deviation number 1, we have high peak, as you see here on the screen. this is what we call high peak. It means it is high. The maximum value of y is larger than when standard deviation is equal to 2 and when standard deviation is equal to 3. But the difference is in the case of area. For the case number 2, standard deviation 2, it has lower peak than curve number 1, as you see from the diagram. The diagram here, this is, when you say, I say high peak. High peak. This point is the high peak. Then another one. So this is high, this is low peak, and also this one is low peak when you compare to the two graphs above the last one. So you can conclude by saying standard deviation 1 is less than standard deviation 2 is less than standard deviation 3. But this one is in the case of area to which the curve take. The curve take. Now, why are we learning normal distribution? Because it is used in solving different problems in spatial probability. But we have another thing. The one that we were discussing was normal distribution. But this one is standard normal distribution. When we say standard, we mean it is standard throughout. Now let's see. When we talk about standard normal distribution, what do we mean? For standard normal distribution, normal distribution. This is a normal distribution having mean equal to 0 and variance equal to 1. That is what we call the standard normal distribution. It has a mean equal to 0 and a variance of 1. As you see its graph here, the graph is like a bell-shaped diagram. Now when we say the mean, this line that is crossing or dividing the curve into two parts, right part and the left part. This is what we call the standard normal distribution, my dear student. Now, standard normal distribution is denoted by letter Z. So, this standard normal distribution is denoted by letter Z, in which it is named Z score. So this Z score is given by the formula. So Z score is equal to the random variable x minus the mean divided by standard deviation. Hope you remember how do we find the standard deviation. Standard deviation, for just reminding you, is the same as taking the root of variance. So that is the standard deviation, in which x is the given variable or the raw mark and mu is the mean. Sometimes here you can use x minus lambda divided by standard deviation. All this mu, lambda, and that one, all these are Greek letters and they have their meaning. Now, let's see how can you standardize a given mark. But before checking example, if variable x approximately 2 or follow normal under mean and variance, and z equal to the variable x minus mean divided by standard deviation, then we simply write z approximate to normal having mean of 0 and the variance of 1. So if you take a square root of 1, you will obtain 1. So sometimes here, do not confuse. This is standard for standard deviation, but here when you are writing it, you are writing in terms of mean and the variance. Now let's see the first example. Example number 1. Suppose the marks scored by student are normally distributed. Normally distributed. So when you say normally distributed, it means its mean or the mean of that data, the mode and median are always equal. With the mean of, so we are given mean. So let's take part of solution. Mean equal to 2. And you are given standard deviation of 0.1. Our question is, using a sketch of normal curve for probability of z, remember z is the z score, the standard one, determine the inequality from the normal variable z given that. So here we have 3 different questions. Part A, when x is less than 2.1. Part B, when x is greater than 1.8. And part C, when x lie between 1.9 and 3. So these are the given variable. Now, how do we determine inequality for this standard mark? So first of all, you need to recall the formula. So number 1 will be equal to x less than 2.1. But remember, this one is distributed in standard normal distribution, in which the z will be given by x minus mean divided by standard deviation. So you may simply write z equal to, what is our x? Our x is 2.1. So it is 2.1 minus, our mean is 2 divided by 0.1. But remember here, you are given x less than. So even the z will also be less. So it will be z less than that value, the one that we are looking for. Now take your calculator and then simplify. So here we'll be having 0.1 divided by 0.1, in which it will give you probability of z less than 1. Now, how do you show that one in the normal curve? The normal curve for this will be, so just draw a curve and then go and represent z less than 1. So we say here is 1. Now, which area show z less than 1? So this is the area showing P of z less than 1. That is case number 1. Second case. The second case, when x is greater than 1.8. So here we are looking for x, probability of x greater than 1.8. But in standard normal, it will be greater than, it will be z greater than 1.8. But also remember, what is z? Z, as I said, is given by this formula. So it is the same as writing probability of z greater than. The formula is x minus mean, so it is 1.8 minus, our mean is 2 divided by 0.1. Now, from there, take your calculator, simplify. 1.8 minus 2, it is negative 0.2 divided by 0.1. So if you divide negative 0.2 by 0.1, it will give you probability of z greater than negative 2. Again, redrawing or showing that under the normal curve, it will be like this. Now, negative 2, so the area that is greater than negative 2, it will be that one. And lastly, let's see when it is between two given variables. Let's see part C. Part C, when x lie between, when x lie between 1.9 and 3. But if you see the word inclusive, it means this value are included. So here we use less than or equal, less than or equal. Now in Z, it will be, the formula as you remember is x minus u, mu or mean, standard deviation, less than z, less than, again, x minus mean divided by standard deviation. So therefore, it will be 1.9 minus the mean is 2 divided by 0.1 less than or equal to z less than or equal to 3 minus 2 over 0.1. Thereafter, use your calculator and then simplify. See which number you obtain. 1.9 minus 2 is negative 0.1 divided by 0.1 less than or equal to z less than 1 divided by 0.1. So if you divide, you'll end in having negative 1 less than or equal to z less than or equal to 1 divided by 0.1 is 10. That is the inequality. But how do you show this under normal distribution curve? So that one will be as. This is our curve, and this is the normal or the mean. So we have negative 1 and we have 10. So that inequality under normal distribution curve will be looking like that one. Now, why are we learning this? Because it has a lot of questions that are normally come in your exam, and you need to know on how to use the normal distribution curve with the help of your calculator. Now let's see general cases on how to use standard normal distribution in solving probability problem. Let's see the general cases. There are about 4, and you need to practice. But if you know how to draw this normal standard curve, it's very easy to know which formula is suitable for a given question. Let's see number 1, condition number 1. If probability of Z score is less than negative A, this one is the same as writing probability of Z greater than positive A. So if you draw the curve, when we say negative, it means this area. So it is the same as finding the probability of Z greater than positive. So positive A, it means in that part. Positive A, negative A. So the same as finding probability from that toward that area. But how do you find it? Taking an example, if you are given the probability of Z less than negative 1, it is the same as taking 1 minus probability of Z greater than 1. Why it is 1 minus probability of Z greater than 1? Remember, total area under the curve is 1. So when you subtract Z greater than 1, this area, you'll be able to obtain the one that is for less than negative 1. So here it is the same as taking 1 minus. Now it's time to use your calculator. But how do I use a calculator? You need to go to mode and make sure your calculator is in SD mode. SD mode. So press 1. So after pressing 1, my calculator is ready now to use. So how do I find P of Z greater than 1? Just go or press shift and then go to distribution, press number 3. So if you press number 3, you'll see letter P, bracket, Q, open bracket, R, open bracket, and so on. But for our case here, just write, we are taking 1 minus shift distribution of P equal to 1. So if you put equal to 1, then you will obtain the value of 0.15866. That is direct, but you need to find the probability of Z when equal to 1 using your calculator. For that case, it is 0.84134. So if you subtract, you will get 0.15866. But also you can use probability of Z less than negative 1 is equal to probability of Z greater than 1. What does it mean? When we say greater than 1, if we redraw the curve, this is Z greater than 1. It means that area. But remember, this part is equal to 0.5, the area in that part. So to obtain this, it's the same as taking 0.5 minus Q of 1. Where do I obtain Q? Again, it is from calculator. So if you use your calculator and you plug, you will see the last value will be equal to 0.1587, which is the same to the above one. So that is case number 1, when you are given probability of z less than negative a. Let's check the second one. Number 2, if you are given probability of z less than positive a, this is just the same as taking 0.5 plus q of a. These are just general. For instance, finding probability of z when less than 3. 3 is just a positive number. So how do I find that one? The same as taking 0.5 plus q of 3. So if you use your calculator, it will be q of 3 is 0.4987. So when you simplify, you'll ending having 0.9987. So that is the probability of z less than 3. That is case number 2. So the third condition. So if you have probability of z greater than positive a, z greater than positive a is the same as taking 1 minus probability of z less than positive a. Or you may simply take 0.5 minus q of a. So you can draw it normal curve and see how this formula is obtained. So if we take z greater than positive a, it means is this region. That's why I'm saying you can use 1 minus probability of z less than or equal to 1. It means 1 is all this minus only this part. You will obtain the value of z greater than a. Or you may just consider just right part having 0.5 as total area minus q of a. So if you use 0.5 minus q of a, you will obtain the same value as using 1 minus p of z less than positive a. Now, number 4. You may be given probability of negative a less than z less than positive a. This is just simply take 2 q of positive a. For example, probability of negative 2 less than z less than 2. Just see here, the difference is sign. This is negative and this is positive. So the same as taking 2 q of 2. So if you use your calculator again, you'll find that it is 2 to the bracket of 0.4773. Opening the bracket by multiplying, you will get 0.9545. That is number 4. So when you draw the curve, here it will be like this. This is the normal or the mean, negative a, and this is positive a. So the area that you are looking is that one. This is the required area. Next, what if you are given probability of negative a less than z less than negative b? So the number now are not equal, and even the sign are not the same or the same. So for that case, it is the same as writing z less than negative b is equal to, now changing by using the symmetrical property, it will be b less than z less than a, in which probability of b less than z less than a is obtained by taking probability Z less than A minus probability Z less than B. For instance, in your calculation, you obtained the following: -3 less than Z less than -2. So first, you redraw that one and see the area. If you redraw -3 and -2. So you are looking for this area. How do we obtain that one? It's the same as taking probability of Z less than 3 minus probability of Z less than 2. Then use your calculator again, plug the value, shift, distribute, take P of 3 minus again, distribute P of 2 and see what will be the value. So the answer here will be 0.0214. But if you decide to read one after another, one by one, this one will give you 0.99865, and the other one will give you 0.97725. So when you simplify to the last point, you will get 0.0214. So my dear student, this part is very important. So practice on how to use your calculator, on how to draw the standing normal curve, and remember to show the normal curve in your solution, because it takes some marks, and it's better to show the area of the curve that you are looking for. Now, apart from that, you can have a question that lead you to change binomial distribution to normal distribution. But here we are dealing with binomial probability distribution and normal probability distribution. So we'll be looking on how to change or how to approximate binomial probability distribution to normal probability distribution. Or in that part, we need to know some conditions. And then we'll see one example. If we'll be having more time, then we'll check another examples. But let's focus on the conditions for approximating binomial probability distribution to normal probability distribution. Condition for that case: when any trial is greater than 10. So any trial, when we say any trial, it means the number of trial or the number of outcome in an experiment. So when any is greater than 10. But not only that, and the probability of success is close to 0.5. When I say close to 0.5, doesn't mean it's 0.5. It means less than 0.5. It may be 0.1, 0.2, 0.3, 0.4, but not 0.5. And the probability of success is less than 0.5. So if probability of success is 0.5, it means the other one of failure will also be equal to 0.5. We'll see example, then you'll understand more. This is case number 1. So if you find a question having number of trial greater than 10 and the probability of success is less than 0.5, my dear student, that is a question concerning approximation on binomial distribution to normal distribution. We'll see example, then you understand more on this condition. Condition number 2, when any trial is greater than 30. So okay, this is the second case. If any is greater than 30 and the probability of success is less or greater than 0.5. So here there is no restriction on the case of probability. So the probability of success is either less than 0.5 or greater than 0.5. But what make you approximate is the number of trial. So if the number of trial is greater than 30 and the probability is either less than 0.5 or greater than 0.5, then you are supposed to approximate that binomial distribution to normal distribution. So for that case, this binomial distribution will be approximated to normal distribution. Now let's see, how do we write? So if all this happen, so variable x under binomial, remember, is given by any p, where any is the number of trial and the p is the probability of success. So if that is the case, or under that condition, this will be approximated to x normal of any p q. Now, what is any p in normal? Any p, this is the mean. And any pq is the variance. So this is when n is greater than 10 and the p is greater than 0.5. Or the second case, n is greater than 30 and p greater than 0.5, or p is less than 0.5. So you'll be using this approximation if you are given this value, number of trial greater than 10 and the p greater than 0.5, then you are supposed to use this one to approximate the binomial to normal distribution. Now, after checking the condition, now let's see how are we supposed to apply this condition in solving question. Or how will you know this question is concerning binomial approximation to normal? Let's see the example. The probability that a person supports a particular organization is 0.3. In a random sample of 50 people, find the probability that at least 20 support the organization. Now, remember the condition. Number 1 is the number of trial. We have two conditions, when n is greater than 10 and when n is greater than 30. Now, what do we have here? We have number of trial as 50. Okay, number of trial is 50. How about probability? My probability of success is 0.3. Okay. Now, this question is under binomial probability approximation to normal distribution. Now, let's see how to solve that question. First, write what you're given in the question. Probability that a person supports a particular, support means that is the probability of success. So let P be the probability of success, in which we are given as 0.3. But also we are given n, this is number of trial, which is 50. That is n. And we have to find probability of at least 20 support the organization. What does it mean? It means let x be the variable or person who support the organization. Now the question is, find the probability of. When we say at least, it means greater than or equal to 20. So x greater than or equal to 20. This is what we are looking for. But remember, when you want to approximate binomial to normal, remember the condition. And that condition is when the mean is given by NP and the variance is given by NP Q. So for that case, we need to find the value of Q. How do I find the value of Q? Remember, P plus Q equal to 1. This is probability of success and that one is probability of failure. So Q will be equal to 1 minus P, to which is 1 minus 0.3, which is 0.7. So that is the value of probability of failure. Now let's check. What is the mean of this question, having n of 50 and p of success as 0.3? Now find the mean. So mean is equal to NP. When you find the mean, it is 50 times 0.3, which is equal to 15. That is the mean. Now checking the variance is NPQ. But you have already NP. Our NP is 15. What is our Q? Is 0.7. Then use your calculator, multiply and see what will be the value. So if you use calculator, 15 times 0.7 is 10.5. Okay. Now let's go back to the condition. The condition is when n is greater than p, greater than 10. So here, if you see here, the mean, so the mean, which is 15, is greater than 10. And also, the variance, 10.5, greater than 10. Now, we approximate the binomial, which the variable was. Our n was 50 and 0.3. This is the same as finding the variable approximately to the normal, but with the mean of 15 and the variance of 10.5. But remember, we are looking for probability of x greater than or equal to 20. That is at least greater than or equal to 20. Now, for correct approximation, this is the same as writing probability of x greater than 19.5. Now, let's use this one as our value. We are writing it into normal standard distribution. And let's see what are we going to get. Now, for that case, so we are standardizing the probability of x greater than or equal to 19.5. So recall the formula for standard score, which is z equal to the variable x minus the mean divided by standard deviation. So probability of x greater than or equal to 19.5 is the same as writing probability of z greater than or equal to 19.5 minus the mean. Our mean here is 15. So it is 15 divided by standard deviation. Remember, this one is the variance. So standard deviation is the root of 10.5. So let's simplify and see what is the final solution. So probability of z greater than or equal to, use your calculator, 19.5 minus 15. Yeah, you get 4.5 divided by the root of 10.5 is 3.24037. Then to the last point, z greater than or equal to 4.5 divided by 3.24037. 4.5 divided by 3.24037. So our value here is 1.3887, to which you may approximate into 2 decimal and be greater than 1.389. Now draw the normal curve showing that area, then go and use your calculator to simplify the value. So under normal standard curve, that is the mean. Now let's show our z. So this is the probability of z greater than 1.389. So that one. We are looking for probability of x greater than or equal to 19.5. This will be equal to 0.5. Remember, as I said, you are looking for this the same as taking this area, which is 0.5, minus the Q of that number, 1.389. So it is 0.5 minus shift distribution 2 of 1.389. So you will get 0.0824. So therefore, probability of x greater than 19.5, or which is the same as saying probability of x greater than or equal to 20, is 0.0824. So to that point, and through that examples that I was explaining here, hope you will be able to answer any question that is concerning binomial approximation, probability to normal approximation distribution problem. And remember, those conditions under normal standard curve and how to draw the curve as I was showing here. Remember to include them in every solution of your probability problem that is concerning with the normal curve. To that point, our session ends up here, but don't miss the next session.